Thank you for joining us virtually to learn about how we were able to bridge the gaps in our advanced manufacturing technician training by using a homemade, inexpensive, portable DC PLC trainer. Hi, my name is Kate Alcott, and I'm the Associate Director of an ATE center located in upstate New York called NEATEC. Our center has been funded by the NSF for the past 10 years. We are hosted by SUNY Polytechnic Institute. I'm also the veteran liaison for the newly created MNTEC National ATE Center. But the star of this presentation is Robert Decker, Professor Emeritus at Mohawk Valley Community College, or MVCC. Although Bob has tried to retire and enjoy some well-deserved relaxation, we keep finding projects for him to tackle. And this one we're about to share with you, this project was a real doozy. MVCC and NEATEC started collaborating on a project several years ago to develop a short, hands-on training program for soldiers about to leave service from Fort Drum Army Base in northern New York. We heard from advanced manufacturing, semiconductor, and nanotechnology industries across the state that they desperately needed technicians, especially those with some mechanical experience and leadership skills. To date, we've trained 9 cohorts of soldiers, exposing them to skills needed for maintenance or tool tech positions. Bob and his mechanical engineering colleague at MVCC, Nate Roskop, have developed the curricula as well as some training tools for the Fort Drum workshops. Bob's 20 years of industry experience and 20 years of teaching bring him instant credibility with the soldiers. He's able to teach to a variety of abilities, and most importantly, is able to explain the why when it comes to industry relevance. The 72-hour technician boot camp tackles advanced manufacturing practices, pneumatic technology, and mechatronics. Bob's Basic Electricity Electrical Controls 2-day workshop is the most recent addition to our training. Here are some pictures of some of the portable, inexpensive training tools Bob and his colleague have assembled. Did I mention that we don't train the soldiers at SUNY Polytechnic or Mohawk Valley Community College? Oh no, this training is all off-site. The Army base is 85 miles away, so we have to have training tools that can travel. Other than the mechatronics training unit, everything else that is used for the labs is portable. So when we asked Bob to develop some content and a training tool, there were several things for him to consider. The electricity and electrical controls training had to be short, 2 days if possible, and geared to a varied audience. Most of the soldiers are mechanics, but their exposure to electrical concepts varies depending upon the equipment they're assigned to fix. Don't reinvent the wheel. Bob was encouraged to use existing NEATEC developed materials where possible. Create a portable training tool that needs minimal tech support while demonstrating the use of basic tools and test equipment. And develop a tool that utilizes standard industrial components, safety devices, wiring methods like DIN rails to provide a practical introduction to the mechatronics trainer. This was the gap in our training that needed to be bridged. The soldiers had a solid mechanical background, but when it came time to troubleshoot the mechatronics unit faults, they struggled with the electrical concepts. Bob needed to provide a hands-on introduction to PLC technology in an affordable format utilizing a freeware version of laptop-based development tool. Rockwell CCW Standard Edition is the software he uses. He had to develop lab exercises that can be performed by small groups. Topics included electricity, electrical controls, and PLCs. And he had to include facilities in the trainer so that it can be used beyond these workshops in other settings like pneumatic, hydraulics, PLC applications, and sensor applications. In the next series of videos, Bob will explain why this additional content was needed before the mechatronics part of our training and he'll show how the trainer is used to teach key concepts.
So the mechatronics trainer that is shown here is what the participants in this workshop will be working on and doing troubleshooting at. This particular trainer has a control panel, has a PLC down at the bottom. All the wiring is done using DIN rail type connectors, and a variety of relays and other devices, sensors are used in this. So what we were aiming to do in this development was to come up with a curriculum that worked on a number of these different concepts and utilized a simpler system that would be easy to reconfigure, wire, and test. Okay. So the curriculum that we developed focused mainly on DC because most of the control elements in the mechatronics trainer operate on 24-volt DC. We were focusing on concepts that would involve some of the basic theory of electricity, voltage, current, resistance measurements, and measurement tools that would be used in troubleshooting. We also focused on the circuit components. We basically wanted to have ideas of series and parallel circuits and switching, loads, and electrical measurements. The simple low voltage circuitry was what was realized in this training. Since the participants have some background in varied areas, including automotive systems, DC measurements were used exclusively to simplify the curriculum. The lecture and lab developments included some basic components of a DC circuit: the power sources, safety devices, conductors, controls, and loads. These are realized in the trainer here. We have a fixed 24-volt DC power supply. We have some maintained and momentary switches. We have a couple of incandescent indicators here. We have an emergency stop switch. And then for the controls parts of the exercises, we have a 3-pole double throw relay and a programmable logic controller. More on that in a bit. We also use DIN rail wiring here. The top row of this 3-row DIN rail is the control inputs and outputs from the relay and PLC. And the row over here is for the switches and indicators. The second row down is a plus 24-volt power supply, and the bottom row is ground. Using basic digital multimeters, we're able to do voltage and current readings. For example, in this circuit, we have a series pair of lamps here. We measure the current in series and talk about that concept so students will understand how to use the meter. And then we also have a voltmeter here, and we can just probe the DIN rail here and see the voltage on each one of the lamps here. And in that way, we can talk about series circuits and talk about how the voltage would be distributed across these two lamps in the 24-volt system. Okay. So the introductory labs connect the components into a basic circuit using the DIN rail wiring. The lectures present the symbols and relate them to the physical devices that are actually used on the trainer itself. In order to identify wiring methods here, we have these cards that go with the trainer that identify terminal numbers for each one of the components that's on the board. And we use the schematic diagram, introduce the schematic diagrams so that students will be able to relate them to the symbols and do the physical wiring. The basic circuits that we use start out with series and parallel switches, where we do things like two-hand controls, and we explain basic ideas of and/or logic. This is followed by some introductions to DC principles and Ohm's law in the lecture. And we can do the voltage, current, and resistance measurements, talk about the ideas of resistance and continuity measurements being performed with no power applied, and fixed resistors, where we do an introduction to the resistor color code. We also talk about using ammeters and using an ammeter in series, and concepts related to measuring voltage. Okay, so after the day one, which basically focused on electrical principles, voltage, current, resistance, terminology that goes along with switches and circuitry, series and parallel circuitry, we move on in day two to electrical controls. In electrical controls, we start out talking about relays because relays are a very common industrial control element. The relay circuits are presented first with a lecture on why relays are used. We talk about the physical structure of a relay, contact types, coils, and then we talk about specialized types of relays, such as timing relays, reed relays, and others, so that we can relate them to industrial circuitry. The trainer itself includes a 3-pole double-throw relay with a 24-volt DC coil, and this is illustrated in the presentations as well. Some of the lab experiments that we perform include momentary and latching relay circuits, and we do some comparisons to industrial controls as well. In this particular wiring setup here, we've just got a basic latching relay where we've got buttons here, momentary switches, doing the on-off switching. We've got our indicators here to show how that works. The idea that when we press the on switch once, we can press it as many times as we want and it's still latched. The off switch unlatches it. This particular relay has an indicator which is useful for showing the status of the whether the coil is energized or not. In this circuit and in these areas, we switch from using schematic capture to talking about ladder logic because ladder logic is more commonly used in relays and industrial circuit applications, and it also transitions nicely when we start talking about PLCs. So after we complete the unit on relays, we progress and start talking about PLCs. The trainer itself has an Allen Bradley Micro 810 PLC built into it, and uses that in conjunction with a freeware software called Connected Components Workbench. This is a standard edition, which is downloadable from the Rockwell Automation site. The connection from the PC through the to the PLC is through a USB cable. In the lecture, we start talking about the advantages of PLCs over relay controls, the multiple I/O expansion that's possible over relays, the fact that they're configurable without rewiring in some cases, that analog and digital input capabilities exists, and that there are functional blocks such as timers, arithmetic and logic functions, and other functional blocks that would require specialized relays in other hardware cases. We talk about single block versus rack-mounted PLCs that are used in the mechatronics training. This particular arrangement that's set up over here uses the matching 24-volt DC power supply that goes with the PLC, although a separate 24-volt supply could be used. This supply also supplies up to 1.6 amps of current for the system here for other connections and to run the peripheral devices. As I mentioned, the programming software is free, so there's no subscription required, and participants could actually download this to a laptop if they chose to. Right here, I'm using the monitoring function of the software so that we can actually see what's happening in real time on the PLC. And this is common to a lot of different types of PLC software. And you can see the ladder logic is used in here. In the experiments that we do in the workshop, students actually go step by step creating the ladder logic and then downloading it to the PLC, wiring the trainer up to have the functions set up in it, and then testing it. And then we can go through here and monitor it and use it for a troubleshooting tool as well. In a broader application of the trainer, we have one of our pneumatics trainers here. And basically, some of the I/O elements that are available in the electro-pneumatic components of the pneumatic trainer can be connected using the DIN rails here. So it would be possible to support doing some electro-pneumatic experiments here under PLC control using the trainer as well.
We hope that Bob's demonstrations gave you a sense of how this inexpensive, homemade, portable trainer can work. So how can you incorporate this tool and curricula at your college? Use it as a plug-and-play addition to existing programs like mechatronics, electrical engineering technology, or mechanical engineering technology. You can also pass this along to your corporate training department to sell as a non-credit workshop for employers. Visit our website at neatec.org to find the trainer design, price list of materials used to build the trainer, and curricula, both lecture and lab materials. We keep telling him that retirement is overrated, so please reinforce that message when you talk to him. For questions, go to the source, rdecker@mvcc.edu. Thank you for your interest in our program.